up. Additional notes. Let's run through this because I think this will help you. Those of you that are like having trouble with the homework, back there in that bin back there where it says honors, back there, I don't know. Okay. So data for air travel is given in the table. Let T be the years since 2000. And F of T be the number of passengers in millions. Find the average rate of change from 2004 to 2019, or 2004 to 2019. Okay, so how do we find that? How do we do average rate of change? It's going to be F of 2019 minus F of 2004 over 2019 minus 2004, right guys? Yeah. Isn't that what it's going to be? Okay, so from my chart, what's F of 2019? 926.7. And what's F of 2004? 703.7 over 50. So I can just type that in. That's how we find average rate of change. We should put a unit on that, so after we get our answer, we'll do that. I got 14.867. Does that sound about right to everybody? Okay, what's the unit on that? That's 14.867 what? Millions of passengers per year. So millions of passengers per year. Okay. Find a linear equation, sometimes called linear model, for F of T. Alright, so now I'm going to get my calculator out and I'm going to do a linear regression. When I set it up, L1, L2, remember your X's are years since 2000, so your X's are going to be 4, 5, 6, and then these guys are going to be whatever they are. Alright, so that's L1, L2. Here we go. So stat edit L1. Oh, I'm so lucky. Mine's still in there from doing it with the other class. So I'm lucky. Tell me when you get them all in. How does your equation look? get this yet? Got that equation? Okay, so this is, I call it an equation, it's called a linear model. This is the model you came up with. Okay, perfect. What percentage of the variation in the data does the model itself explain? In other words, how much of the variation in the y's can be explained by the x's? That's R squared. So about 66.513%. This model has issues. That's not all that great. I wonder what's going on. Did you notice anything as you were putting in the data? As you were just typing in those numbers, did you notice anything that kind of made you think twice, Patrick?
Like it wasn't like linear, and like sometimes it would go up by a lot year to year, and sometimes it would go up by a little year to year.
And sometimes it went down.
Yeah. Right?
So overall, building a linear model for this makes sense because the relationship should be linear. But man, when I look at the data around 2007, 2008, 2009, how could we explain that? I mean, this is actual data. I took this from somewhere. I didn't credit it. I should have, but I took this from somewhere. Can you think about what happened? What caused
the recession?
What?
The recession.
The big recession. Remember when we had the stock market crash? It wasn't quite as bad as back in the 1920s or whatever, but it was pretty significant. So when the financial world went all to heck, what do you think happened to airplane travel? Of course it went down because nobody had any money to fly, right? People canceled their vacations, people canceled business trips because no one had any money. So the model does not take into account that real life fluctuation. So that's why we have a relatively low R squared value. But anyhow, it is what it is, it's what we have. What is f of 23 and what does this mean? So how do we do this? How do we find f of 23?
23 for x.
Exactly. Now there are other ways to do it, but it's just as easy to just put in 23 for x. That's not going to take you any longer than any other method to do it. And what do you get when you put in f of 23? When you do f of 23? 904.169. And that would be millions, right, of passengers. What does that mean? What does this number represent? What does the 904 million represent? How many passengers will fly in 2023 according to our model? What is the residual for f of 16 and what does it mean? Okay, if you have your calculator set up, if you go to Stat, Edit, and click across, and you need to go all the way across to your last column, and you need to go across from the 16. It'll have your residual there. I got, mine is negative 0.9774. Anybody else have that? If you want to calculate that by hand, how do we calculate a residual? What is it? What is a residual? What is that? Residual is the I had this written on the board before. We should know what this is. Actual minus predicted. Yep. So we know the actual value. This is for 2016. So the actual value is 824. 824. And then how would we get the predicted value? We plug 16 into our model. I got 824.9774. Wow. What's the residual then? Exactly what my calculator said it was, right? Okay. What does that mean? What is the residual and what does it mean? What does this tell me about my model? If the residual came out, first of all, it's really close, right? It's really close, but it came out negative, which means what? The model overestimated a little bit for that particular point. The model overestimated a little bit. All right. Now, number 2. Now we have another table. Create a quadratic regression where x equals, actually that should be t, equals the elapsed time in seconds, and f of x is the number of inches a ball traveled down an inclined plane. Okay, so after 1 second, the ball has traveled 1.2 inches, and so on. That's what that means. Create our quadratic model. All right, so what do we need to do? Go to Stat Edit, and we're going to get rid of all that stuff we just put in. And now put this in. We want a quadratic model this time. Oh my gosh. Is that what you got?
Yeah.
What's your r squared this time? What does that mean? That means we're right there. Yeah, everything's perfect. It's perfect. Okay, so according to the model, when will the ball have rolled 41 inches? Okay, so what do I do? When will the ball have rolled 41 inches?
41 for Y.
41 for Y, that's right. And just square root this guy. Did you get about 5.845 seconds? Now, could you have done that a different way? What if you graphed this parabola? Could it look like this? Is there a place where it's 41 inches high, or where the gravel is 41 up like this, could you have used your intersect feature on your calculator and found that point? Yep. This one you would have ignored because that's negative time. All right, graph the residual plot. Well, this is going to be really boring, but we'll do it anyway just to practice doing it. So how do we graph the residual plot? We go back to our stat plot, which should be turned on from other times. If it's not, turn it on. And then for Y list, X list should be L1 because you want to plot your X's. And then for Y list, we're going to plot our residuals. So go to Y list, then go to second stat, that's your list button. Go down and choose residual, and that will make Y list the residual. Hit graph. Get rid of any other equations you might have in there from another day, and hit zoom stat. And this is not going to be a very interesting picture. Because what happened, we have 1, 2, 3, 4, 5, 6 points, and aren't they all right on the axis? Because why? We already talked about it. The residuals are 0. The points are right on the curve. This wasn't random data. This was somebody rigged this. But doesn't get any more perfect than that. The residuals, remember, they represent how far away you are from the actual points, how far the prediction is from the actual points. And since the residuals are all 0, it means the actual points are on the model, right? Normally what we see is, point up here, point down here. Normally this is the kind of thing we see. But not this time, because they're all right there. Okay, what is the residual for 10 and what does it mean? Well, what is the residual going to be? It's going to be 0 because all these points are right on the curve, right? Number 3, write the equation of a quadratic function containing these 3 points without doing regression. Okay, now it's not telling you you can't use your calculator, it's telling you you can't use regression. Okay, so who's got an idea about this? Josie? Exactly. Josie says, look, if I have to build a quadratic equation, isn't that what it's going to look like? If my calculator did it, that's what it would look like. So I know that if y is -3, x is 1. So I'm going to put 1s in for my x's. 1 squared is 1, 1. Okay, so there's the first equation. I do the same thing. -7.5. That will be 4a, because now I'm putting in 2. So 4a plus 2b plus c. And now I'll put in -1. So another a minus b plus c. What do you think? Those equations look okay? Now what do we got? 3 equations, 3 unknowns. How do we solve that? We've already done this earlier. How do we solve something like this? Substitution or elimination? I would do elimination personally, but you can do substitution if you want, whatever. The key here is, you gotta do 2 eliminations and eliminate the same variable both times. So what do you wanna eliminate? It makes no difference, but pick one. What do you want to eliminate? Huh?
First and third.
What letter are you eliminating? B? All right, he wants to eliminate the B's. So he says if I add the first and the third, then my equation will be, and there's decimals and stuff, use a calculator if you need help. We're adding the first and the third, so negative 9 equals 2a plus 2c. Is that okay? Now, as soon as he decided to eliminate b, he's got to do it again. So now he's going to put 2 other equations, second and third, and he's going to eliminate the b's. Now, it's not going to be quite as easy this time, because to eliminate the b's, he's going to have to multiply the bottom one by 2. So negative 12, 2a minus 2b plus 2c. Okay, so if I did that right, I got negative 19.5 equals 6a plus 3c. And then eliminate again. Probably the easiest to get rid of those a's. So I'll multiply this one by negative 3. You can get rid of the c's, it doesn't matter, get rid of something. So 27 equals negative 6a minus 6c. Alright, so what is that, 7.5 equals negative 3c. Does c equal negative 2.5? Alright. Almost there. Now what?
Plug in negative 2.5 to the top.
One of these guys, right? One of these. So it doesn't matter. So let's see. Negative 9 equals 2a minus 5. I got negative 2, is that right? And then what? All the way back to the beginning, one of these. So negative 3 equals negative 2 plus b minus 2.5. So I got negative 2x squared plus 1.5x minus 2.5. Is that okay with everybody? Good with that? Okay. All right, so let's put that away. Hopefully that cleared up something or other. I want to give back your last quizzes. You know, we got everything we got. Oh, okay, so I want you to. Oh, actually, that's okay. Those are important. That's okay. Put those extras back in there.
Yeah. She literally told me to say, did I still